All right, we are looking now at 11.5, day 2. The same idea we did before, we're looking at common denominators. So when you look at this first problem here, you see they both have a common denominator of x minus y. So you don't need to do any extra work there, but there is some simplifying. So what I'd like you to do is to try this, try them both, see what you get. I think you might get all the way there or you might get partially there, but push pause, try these, and come back for the answers. Right, what you'll see here is I had a common denominator. So again, remember, just like we did in the last lesson, you're not adding denominators. You didn't do that before. If you had 1/4 and 1/4, you told me and combine those, you would get 2/4. You wouldn't get 2/8. So always keep the denominator the same. So that's why this is just x minus y. And I rewrote the top 5x minus 5y. Since I already had a common denominator, I didn't have to do anything to that. Then I said, oh wait, this has a common, greatest common factor of 5. I factored that out. That led me to having two common factors. X minus y divided by x minus y gives me 1. 5 times 1 is 5. In the next one, the same idea. I had a common denominator. So I just rewrote my numerators together over that common denominator. I saw the denominator had a common factor of 2. So I factored that out. These cancel, and I'm left with 1/2 because a plus b divided by a plus b is 1. Remember, when we cancel, we're dividing. So anything divided by itself is 1. Okay, in the next one, a next set again, and this is what we did in class. I'd like you to try and work through it first, and then come back and check your answer. And it's okay if you make mistakes. Nobody's looking, but at least then you'll have thought about it, because you'll learn it better if you think about it and make a bunch of mistakes than just to hear me talk and copy. All right, what I did over here is I factored out, whenever the denominators don't match, I'm going to factor those out. So what I did here was I factored out the greatest common factor of 6 and the greatest common factor of 4. And I said, okay, they both have an r minus s. I need this number in front to match. So I'd like it to be 12. That's the least common multiple of 4 and 6. So I multiplied top and bottom by 2. That's where I got the 10. And now this is a 12 times r minus s. 3 times 3 is the 9. 10 minus 9 is the 1. Again, 12 times the quantity r minus s is the denominator. You're not adding or subtracting the denominators. The denominator just comes along for the ride. It's the description of what we're combining. I'm doing hand motions. You guys can't even see. I'm like trying to describe. Over here, I did the same exact thing. In the denominator, I factored out. I took a GCF out of each. I said, okay, they both have an a minus b. This one has a 4. So if I multiply top and bottom here by 2, then that gives me the same denominator of 4 times a minus b. And then 2 plus 1 is 3. Denominator comes along, and that's the best I can do. So there's your answer for that one. Now in the next one, I'm going to warn you about some things. In this one, what I commonly have people do, don't do this, is they say, oh, I just multiply this by -1. The problem with that, because they think, oh, that'll give me a -1. The problem is if you multiply this by -1, you get negative x minus 1. That's not the same as this, so don't make that mistake. That's a very common mistake that happens. Okay, these are, I'm going to put little force fields up on them. Okay, what I have here, can you factor this out at all? GCF, binomials? No, that doesn't work. I factor this out at all? No. Well, what did you do before when you had numbers like 7 and 5? Like if you had 1/7 and 1/5. They don't share any common factors, so what did you do to get that common denominator? Well, you multiplied by the other one. So you multiplied this by 5 over 5 and that one by 7 over 7, and that's what we're going to do here. Okay, so you're going to multiply this one by x plus 1 over x plus 1, and you're going to multiply this one by x minus 1 over x minus 1. Now, what you may want to do is kind of see me work through this and then come back and try and do this one by yourself. So I'm going to go through the answers now, but if you'd like to push pause and see if you can get it yourself and check back, that's good too. But again, make your mistakes. It's okay. At least you'll have thought about it, and then that makes that stick in your brain a little better. So you can see here I multiplied left side by x plus 1, x plus 1. It's the same as multiplying by 1, so it doesn't really change the fraction. This side by x minus 1, x minus 1. Then what I did is I rewrote on the top what I have. I have 1 times x plus 1 plus, that got brought down, 1 times x minus 1. All over the denominator. Remember, we don't add the denominators or multiply. This was the common denominator. That is what comes along with it, the common denominator. I distributed the positive 1 for each, and then I combined the like terms. All right, if you'd like to go back to here now and try this one on your own, you can do that. It's the same idea. You're going to have to, they don't have any common factors, so you're going to have to multiply one by the other. Okay, so multiply top and bottom by x plus 4, x plus 3, and work it through. Come back to check the answer. Right, over here you'll see what I did, x plus 4 on this side, x plus 3. I wrote what I have now. I have x times x plus 4 minus, see how the minus came down, 2 and the x plus 3. I distributed the x, I distributed the negative 2, and then I combined. Now, you can check to see if this can be factored, because sometimes it might be able to be factored. In this case, it can't. One way to check to see if it can be factored is to use the discriminant test. If you don't remember the discriminant test, just stop in and see me, and I'll remind you how to do that. All right, for the last ones, craziness. These are crazy. Now, again, what I'll have people do is they'll say, oh, I'll multiply this one by 7. If you multiply that by 7, you're getting 7x minus 7. That's not what this is, so that's not going to work. They don't have any common factors, so multiply this one by x minus 1, x minus 1. Oops, sorry. And this one by x minus 7, x minus 7. So again, if you'd like to try and work through it, you can. Or if you want to keep listening, I'm going to talk through this problem, and then you might want to go back to that one. So here you can see I multiplied to get the common denominator. So this one will now have x minus 7, x minus 1, and so will this one. I rewrote what I had at the top. So at the top I have this plus this. Don't cancel here. No. That's an angry face. Don't cancel at this step. That's the most common mistake I see. Common denominators simplify. If you try to cancel these, you're canceling a term because this whole thing is being added with that whole thing. Can't cancel. So what I did is I multiplied these right here, and then I multiplied these binomials together. That's where this trinomial came from. So multiplied the binomials. Now I'm going to combine the like terms. That's what happened here. This cannot factor. Again, check if it can factor. You can use discriminant test to help you. All right, now over here, common denominator. Okay, I wrote what I have. So I have x plus 4, x plus 5. I have a minus. Notice that minus there. That's important. X minus 2, x plus 6. I multiplied the x plus 4, x plus 5. That's me multiplying that out. Use your area models. I multiplied these two binomials out, but notice I left it in parentheses. I did that because this is a minus. In the next step, I distributed that minus 1 through. So you'll see the sign change here. Combine my like terms, and I got to here. So I know these last two are pretty crazy and intense. I won't give you a ton of those. But again, the biggest mistake I usually see is doing this, getting the common denominator, and then canceling. And that's not what you're supposed to do. So listen to the sad face. And that is 11.5 day 2.